Let's look at how we add and subtract radical expressions. In the first column, we see we have like radicals. Like radicals are radical expressions with the same index and the same radicand. Let's look at the first problem. Square root of 10 plus square root of 10. Now, you might be inclined to say, oh, that's easy. It's the square root of 20. Not so fast. Let's take a moment and look at what we have here. So we have 1 square root of 10 plus 1 more square root of 10. So what we do is we add together the 1 plus the 1, and we keep the radical 10 the same. This means we have 2 square root 10. That should sound familiar to you. It's just like combining like terms. Let's look at the second problem. We have 3 square root of 2 plus 4 square root of 2, which means we have 7 square root 2. Remember, we can only use this process when we have like radicals. That means that both radical expressions have the same index and the same radicand. Square root 11 plus 5 square root 11. They both have an index of 2 because they're square roots, and they're both with a radicand of 11. 1 radical 11 plus 5 rad 11 gives us 6 rad 11. In the last one, we each have an index of 3 because it's the cubed root of 9, and the radicand is 9. 1 cube root 9 plus 7 cube root 9 gives us 8 cube root 9. Be careful when you have an index showing like a 3. Make sure you can tell the difference between the number being multiplied out front, which is the 8, and the index of 3. Make sure you can tell one is the 8, that you can tell that one number is the 8 that's being multiplied, and that the 3 is the index. The 3 should be a lot smaller, and it should be in the little crook of the radical sign. Let's look at the column for unlike radicals. When you have unlike radicals, you either have a different index or a different radicand. In the first problem, I have an index of 2 because they're both square roots, but I have different radicands. What that means is I cannot combine these. One has a radicand of 5 and one has a radicand of 2. Same thing for square root 6 plus square root 3. Those expressions have a different radicand. Same thing with 4 square root 19 minus 4 square root 3. One has a radicand of 19, one has a radicand of 3. In the last example, they have the same radicand, 13, but the first one's a square root and the second one's a cube root. This means we have a different index. So none of these expressions can be combined because they are unlike radicals. So we cannot combine them or simplify them. Okay, let's take a look at some more. Sometimes we might look at what we think are unlike radicals and say that we can't combine them, but we might just need to simplify first. In the list of unlike radicals above, that's what we looked at on the previous slide, we could not combine the radical expressions. But just because radicals are unlike doesn't always mean we can't combine them. Sometimes the like radicals are hidden because we have to simplify first. Consider, for example, square root 8 and square root 50. At first, you might look at those and say, well, the radicands are different, so I can't combine them. But look at what happens when we simplify. Square root 8 becomes 2 rad 2, and square root 50 becomes 5 radical 2. So after we simplify, the radicals actually are alike. Let's take a look. So the square root of 8, as we saw above, becomes 2 radical 2. And the reason why we are able to get 2 radical 2 is because the square root of 8 is 4 times 2. Now, let's look at square root 50. Square root 50 becomes 5 radical 2. And the reason it's 5 radical 2 is because square root 50 becomes square root of 25 times 2. Now, I'm able to add those two radicands together. I add the 2 plus 5 and multiply by the square root 2, which gives me 7 radical 2. So at first glance, I might have thought that I was unable to combine these radicals, but really they did turn out to be like radicals, and my final answer is 7 radical 2.